Uh, so we'll be starting with the forces, the exogenic processes, endogenic processes, and all. Okay, then I'll take you to the this hill slopes. Okay, and then some of the geomorphic cycles will study. So this is our agenda for today. Okay, so let us begin with the forces. Okay, endogenetic and exogenetic processes. Okay, these endogenetic and exogenetic processes. Okay, so now the study of forces affecting the crust of the earth of geological processes is paramount significance, right? Geomorphology, right? This subject of geomorphology is entirely based on the shape of land features. Okay, this is nothing but the shape of land features. How the land features have taken shape, how the land features are developed, how what is the fate, ultimate fate of the features present on the land, right? So it is for utmost important for us to know about by with which processes or with which forces, okay, due to which forces these geomorphology or these shapes of landforms have been formed, right? So there are two types of forces. Okay, there are two types of forces. These forces very often affect the change the Earth's surface. Okay, the geological changes are generally of two types: long period change and short period change. Okay, long period changes and short period changes. So long period changes occur so slowly that man is unable to notice in his life period. Right, just like uh, this mountain building. Okay, mountain building or subduction zone. Right, better example is mountain building. Okay, we cannot directly see or we cannot directly observe the mountain getting rise. Okay, say suppose this is a plain land. Okay, say suppose this is a plain land. You are walking daily on this road, along this road, and one fine day you see suddenly a mountain is standing over there. Okay, a mountain is standing over there, a hill standing over there, right? You cannot see that. Okay, or there is a hill, and one fine morning, okay, one fine morning you see that there is no hill at all, right? There is no hill at all. So these kind of forces, okay, this kind of forces or this kind of processes cannot happen, right? These processes, okay, these processes or these changes are called as long period changes. Okay, these are called as long period changes which take very large amount of time to occur. Okay, on the other hand, short period changes that take place so suddenly that these are noticed within few seconds or few hours. Okay. So the best example for this is earthquake. Okay. Earthquake. Sudden process is there. Okay. Even before you know, okay, even before you come to know what actually happened. Okay, what actually happened. Seismic wave will strike on the earth surface, right? Seismic wave strike on the earth surface, it will destroy everything and will diminish, right? It is impossible to know about the seismic waves, when they will strike, where they will strike, right? So it is actually impossible, and these forces or these changes, okay, these changes are sudden changes or short period changes, right? So these are the two types of changes which are occurred on the earth's surface, right? The forces which affect the crust of the earth are divided into two broad categories. So there are two broad categories in which the forces are uh, divided, right? These are endogenetic forces and exogenetic forces. Okay, the endogenetic forces and exogenetic forces. Basically, endogenetic means endogenetic processes are those, okay, forces are those forces which come from within the earth, okay, which come from within the earth, which earth has itself, okay, from the interior of the earth, just like seismic waves or volcanism. Okay, seismic waves, volcanism or plate tectonics, these are endogenetic processes. Okay, these are endogenetic processes. Then what is exogenetic processes? Exogenetic means which occur on the surface. Okay, these are the processes or these are the forces which occur on the surface of the earth, just like weathering, just like erosion. Okay, understood. So these are the exogenetic and endogenetic processes or endogenetic and exogenetic forces, right? So these endogenetic forces, the forces which come from the forces coming from within the earth are called endogenetic forces. Okay, they are called as endogenetic forces, which cause two types of movements in the earth. That is horizontal movement and vertical movement, either horizontal or vertical, right? So these movements motored by endogenetic forces introduce various type of vertical irregularities, which give birth to numerous varieties of relief features. Okay, volcanic eruptions and seismic events are also expressions of endogenetic forces. These are also the endogenetic forces which why because they are coming in from inside the earth. Okay, such movements are called sudden movements, and the forces responsible for their origin are sudden forces. Okay, so these are called as sudden forces or sudden movements. Right. We do not know precisely the mode of origin of the endogenetic forces and movement because they are related to the interior of the earth. Okay. So I just have told you it is impossible to know. Right. It is actually impossible to know when these endogenetic forces will work and when this earthquake will strike, when the seismic waves will strike the earth and will destroy everything. Okay. Got this? So these are called as exogenetic and endogenetic processes or endogenetic and exogenetic forces. Okay. So this entire thing can be summed up in this one chart. Okay, this entire thing is summed up into this one chart, right? So these are endogenetic forces, okay, endogenetic forces and exogenetic forces. Okay, the endogenetic forces and exogenetic forces. Now these endogenetic forces are of two types. Okay, the endogenetic forces are of two types: diastrophic forces and sudden forces. Okay, diastrophic forces and sudden forces. So diastrophic forces are basically the slower forces. Okay, these are slow force. Okay, these are slow force, and sudden forces are faster forces. Okay, diastrophic forces are slower forces, and sudden forces are faster forces. Right. Now, diastrophic forces, they are divided into again for they are further divided into two: epirogenic and orogenic forces. Okay, epirogenic forces and orogenic forces, right? Now what is this epirogenic forces and orogenic forces? They are the two different processes: epirogeny and orogeny. Okay, orogeny and epirogeny. So this epirogeny, okay, epirogeny is divided into, okay, is divided into either upward movement, okay, upward movement or downward movement, either emergence, okay, either emergence or submergence. Okay, like this. Okay, this is eparogeny. Okay, eparogeny or eparogenic forces. So either it will be upward force or it will be downward force, downward movement. And then orogenic movement. Okay, the orogenic movement has tensional forces and compressional forces, right? Tensional forces and compressional forces. Okay, so these tensional forces are represent this they are divided into crustal fractures. Okay, these are crustal fractures. Okay, the crustal fractures which fractures the crust. Okay, which actually fractures the crust. Okay, in which we have cracking, just the cracking, which will give rise to jointing or the formation of joint, right? Jointing or the formation of joint, and faulting. Okay, formation of faults. Okay, the formation of faults. That means any kind of fault which we have learned. Okay, I have given you the detailed account of faults, right? I have given you detailed account of faults, types of faults, how do they develop, and or everything, right? So any kind of fault can be considered under this crustal fracture, right? Whereas in the compressional forces, okay, in case of compressional forces, it is crustal bending. It just bends the crust. Okay, it just bends the crust like this. Okay, so there is warping. Okay, there is warping or folding, right? Warping means twisting. Okay, so it may be unwarping, upwarping, or downwarping. Okay, either it may be upwarping or it may be downward. It will twist the surface. Okay, it will twist the surface upward in upward movement, or it will twist the surface in the downwards movement. Right? And folds and folding. We know folds and folding. What are these folds? I've given you the detailed account of folds as well. Right? So folds and folding, everything, all the folds are covered in this crustal bending. Okay. Then comes the sudden forces. Okay. Then comes this sudden forces. Now, in these sudden forces, volcanic eruptions and earthquake, these are the sudden forces which take place when the earth uh, outpours something. Right. In volcanic eruption, earth outpours magma. Okay. Earth outpours magma when it comes on the surface is called lava. And then is earthquake. Okay. Earthquake in which seismic waves. Okay, the seismic waves strike the earth. Okay, seismic waves strike the surface of the earth. Right. Seismic waves strikes the surface of the waves and virtually shakes the earth. Okay, it virtually shakes the surface of the earth and almost destroys everything. Right. So these are the sudden forces, and this is a detailed account of this endogenetic forces. Okay, these are the endogenetic forces. What is this exogenetic force? Exogenetic force. Exogenetic force is nothing but weathering and erosion. Okay, these are nothing but weathering and erosion. Whatever landforms are developed, okay, whatever landforms are developed, whatever features are developed on the surface of the earth, okay, whatever features are developed on the surface of the earth, these are nothing but the exogenetic forces. Okay, these are nothing but due to the exogenetic forces, right? So this will be everything which is related to this weathering and erosion activities. Okay, everything which is related with weathering and erosion activities, they come under, or one more thing, it is deposition, right? That is deposition. So all these things which are covered under this, okay, the things which are covered under this, they come under this, under the purview of the exogenetic forces. So everything which is happening on the surface, the landform modification present on the surface of the earth, right? These are exogenetic forces. Okay, the exogenetic forces, and whatever forces come from within the earth or on the body of the earth, those will be endogenetic forces, right? So this is the distinction between these endogenetic and exogenetic forces, and these are nothing but the processes of endogenetic and exogenetic uh, forces or endogenetic and exogenetic processes which shape the landforms on the earth. Okay, got this? समझ में आया? This is nothing but your endogenetic and exogenetic processes. Okay, now moving towards the next topic. Okay, moving towards the next topic, and that is cycles or geomorphic cycles. Right, the geomorphic cycle. Now, as we know, the geomorphology. Okay, geomorphology is basically a cyclic process. Okay, it is a cyclic process. That means the processes which are operating on the surface, or processes which are shaping the planet earth, they operate in a cycle. Okay, they operate in a cycle. So one thing which has been started will end and will start once again, right? One thing which has been started will end somewhere and will start once again. So this cycle goes on, right? This cycle goes on. So this cycle of erosion, okay, the cycle of erosion which gives rise to the geomorphic landforms. Okay, which geomorphic landforms. So these will be called as the geomorphic cycle. Okay, these are called as geomorphic cycles. Okay, so cycle of geomorphology, cyclicity in the geomorphology, and that is nothing but the geomorphic cycle. Okay, so there are various types of geomorphic cycle. Basically, this idea, okay, this idea was propounded by James Hutton. Okay, this idea first was propounded by James Hutton, and then people took the idea. Okay, people took the idea and developed it. Okay, so cyclic nature and the dictum of no vestige of beginning and no prospect of an end. That is, present is key to the past. This is the most famous statement in geology. Okay, most famous statement in geology, and everybody knows it. Okay, so present is key to the past, which is actually called as uniformitarianism. Okay, it is uniformitarianism. But nowadays, this uniformitarianism has been challenged. Okay, this uniformitarianism has been challenged by actualism. Okay, the uniformitarianism has been challenged by actualism, right? So uniformitarianism considers that the processes are similar. Okay, the processes are similar, which the process which has been which is operating today, that has been operated till the history, throughout the history of the earth, with or without the same intensity, right? With or without the same intensity. But actualism carries out actualism works out on the forces or on the intensity of the of this process, right? Intensity of the process. At what intensity how that process has been proceeded, right? So that is actualism. We don't have to go into this actualism and uniformitarianism debate. Okay, I just given you for your general knowledge. Okay, nowadays this theory is grabbing the roots. Okay, now this theory, which was given by James Hutton, okay, then developed by people. This was more popularized by Davis. Okay, so he presented his concept of cycle of erosion under the title of geographical cycle of erosion. Okay, geographical cycle of erosion. So the concept of complete cycle of river life, because the river geomorphology. Okay, the river cycle. Okay, river cycle presents a most perfect or most unique type of features which are present. Okay, it presents youth, mature, and old stage. Okay, youth, mature, and old stage. A perfectly balanced stage. Okay, perfectly balanced type of cycle is there. Okay, perfectly balanced type of cycle is there. No other geomorphic agency or no other natural agency can have or has basically these this much amount of highly distinct phases of their development, right? So the Davison model of geomorphic cycle of erosion was based on the basic concept of sequential change in landforms through time, like evolution of an organic life. So that is the basis of its theory. Okay, that is the basis of its theory. But the theory is very much useful for us. Okay, so Earth's surface is affected by two types of forces. I have told you just now. Okay, I have told you just now that these two types of forces are there. Okay, endogenetic forces and exogenetic forces, wherein endogenetic forces create vertical irregularities. Okay, endogenetic forces create vertical irregularities like this on the Earth's surface by forming several types of relief features of different dimensions. Okay, whereas exogenetic processes originating from the atmosphere try to remove the vertical irregularities created by endogenetic forces. Okay, this is nothing but the balance. Okay, endogenetic and exogenetic forces, they try to balance each other. Okay, become successful in bringing down the reliefs of low featureless plane called a peneplane. Okay, this is called a peneplane. So peneplane is basically a featureless plane. Okay, it's a featureless plane. There is nothing on in this earth which is featureless, right? Which is featureless. This is like concept. Okay, this is just a concept. Nobody has seen a peneplane, right? People have always imagined what peneplane or which kind of thing a peneplane should be or should have been, right? So this kind of featureless plane, okay, this kind of featureless plane, and even if the plane is featureless, that itself will become a feature. Okay, that itself will become the feature, right? So that is a flat plane, which is completely featureless, which does not have anything, which does not have any undulation, which does not have any crack, which does not have any joint, okay, which does not have any intrusion. Okay, so these kind of planes, they will be called as peneplane. Okay, they will be called as peneplane, and the process of formation of peneplane will be called as peneplanation. Okay, the process of formation of the peneplane is called as peneplanation. Peneplanation is nothing but process of erosion, right? Peneplanation is nothing but the process of erosion, because the ultimate fate of any feature or any landform or any area is to become a peneplane, right? Ultimate fate is to become the peneplane, right? So, as the Davis defined, the geographic cycle is the period of time during which an uplifted landmass undergoes its transformation by the process of land sculpture, ending into a low, featureless plane or peneplane. Okay, so this is nothing but your definition for the geomorphic cycle. Okay, this is the definition of a geomorphic cycle or geographic cycle, whatever you want to call it. Right. Now, so geographical cycle of Davis. Okay, the geographical cycle of Davis, which he has proposed. Okay, which he has proposed for the study of this geographical cycle or geomorphic cycle. Okay, so what his theory is all about? His theory is all about this. There are sequential changes in landforms through time. Okay, passing through youth, mature, and old stages, and these sequential changes are directed towards well-defined end product development of peneplane. Okay, there are sequential changes. The changes should be sequential. This should not be random. Okay, this should not be random. It is not like first youth stages there, then old stages there, and then mature stages there, or it can be other way around. First you are finding the mature stage, then you are finding old stage, then you are finding youth stage. This shall not occur, right? This shall not occur. There should be a sequence, right? There should be a sequence, and this sequence should be youth. Okay, youth, then mature, then old, right? It is just like the human evolution, like human evolution or human growth, right? When a kid gets born, okay, it is a young infant. Okay, it is a young infant, and as it grows, okay, as it grows, it enters into youth life. Okay, it enters into young life, then adulthood, right? That is mature stage, and then old life, which is the final stage of life, and then death, right? So this is a sequence, right? This is a sequence. So ultimate fate of any human body, right? Ultimate fate of any human body is death, right? Is death. Okay, agreed or not? The ultimate fate of any human body is death. So this will be a cycle of human life. Okay, this can be a cycle of human life. the youth stage, then the mature stage, then the old stage, and then death. Right. Same way, there is a sequential change in the landforms as the time passes by. Okay, as the time passes by, right? So it is youth stage, young stage, the very juvenile stage, then mature stage. Some maturity has occurred. Some forces are reduced. Some forces are gained. Okay, and the old stage, forces are completely reduced, completely given up. Just the uh, just some of the forces are or something it is driving. That's it, right? So these sequential changes are directed towards a well-defined end product. Just like human death, it is a well-defined end product, and that is called as peneplain. Okay, that is called as a peneplain. Understood? So this is peneplain and peneplanation. So this is the basic idea behind the geomorphic cycle or geographic cycle. Okay. Now, there are three factors. Okay, there are three factors which govern the process of peneplanation or process of geomorphic cycles. Okay, this is a geomorphic cycle. So these three processes or these three factors. Okay, these three factors or three processes, they are structure, process, and time. Okay, the structure, process, and time. So these are the three factors which play a major role in the formation of cycle of erosion or geomorphic cycle. They are basically the drivers of geomorphic cycles. So these three factors are called as trio of Davis. Okay, these are called as trio of Davis. Right. Landscape is a function of structure, process, and time. Okay, remember this line. Okay, remember this line. Landscape is a function of structure, process, and time. This can be a potential question for you. Okay, this can be a potential question for you. Landscape is a function of blank dash dash. Right? This can occur. Okay, this can happen. Or landscape is a function of structure, process, and dash. Structure dash time dash process time. Okay, this kind of questions can be asked. Right? This kind of questions can be asked. So structure means lithological and structural characteristics of a rock. Okay, lithological and structural characteristics. So lithological characteristic means the type of rock. Okay, a type of rock, whether the rock is igneous, whether the rock is metamorphic, whether the rock is sedimentary, right? Whether these kind of or these one of these three rocks are there. Okay, whether one of these three rocks is there. This is the lithological characteristic or lithological structure. Okay, that will be called as a rock type. And structural characteristics means those characteristics which we study in structural geology. Okay, that is folding, faulting, jointing, all these things. Okay, whether the rock is folded, whether the rock is faulted, whether the rock is jointed, because on the basis of that, the type of erosion, okay, the type of erosion or the type of style of erosion will depend. Okay, if the rock is heavily jointed, if the rock is heavily faulted, if the rock is heavily folded, then different kind of weathering will occur. Okay, easier weathering will occur if the rock is highly jointed, right? But if it is compactly jointed or it is compact rock, it won't be broken so easily. Okay, it won't be weathered so easily, right? So the structure will play, okay, a structure will play a major role in case of this formation of the geomorphic cycle. Okay, so this is one factor or this is one feature, right? Second thing is time. Okay, second thing is time. So time was not only used in temporal context but also used as a process itself. Okay, it has been used as a process because as time goes by, okay, as time goes by, as very famously we call समय बड़ा बलवान, right? समय बड़ा बलवान, so बोलते, ठीक है? So as the time passes by, okay, as time passes by, what occurs? Everything gets weakened. Okay, everything gets weakened, right? So whenever you keep anything unattended for several amount of time, okay, keep anything unattended for some amount of time. Say a rock or piece of iron. Okay, don't attend anything. Don't even look at the piece of rock or piece of iron. After considerable amount of time, like say 2 years, 5 years, 10 years, you will see the change in that piece of rock or piece of iron. Okay, if the piece of iron is there, it will be completely rusted. Okay, it has been completely rusted and it has been weakened than that of the original one, right? It is weakened than that of the original one. But in case of the rock, majority of the things might have been removed off, right, due to weathering. Okay, obviously it won't be that visible. Okay, it won't be that visible to us for a rock, but in case of iron or piece of iron, it will be completely visible, it will be clearly visible, right? So time is a factor. Okay, time is again a factor in case of the geomorphic cycle, right? And the process. Okay, and the process. Now what is this process all about? Process is the agent of denudation acting. Okay, the agent of denudation, right? So agent of denudation means the geomorphic or the natural agent with which the agent through which, or the process through which, the weathering action is going, right? The weathering action is going on. Okay, so weathering and erosion, both these things combined together. Okay, both these things combined together will form the factor which is called as process. Okay, the factor which we called as a process. So this process might be water, this process might be wind, this process might be glacier or anything, right? Anything from this can be a process and can be covered under this heading, right? Essentially process is nothing but the agent. Okay, process is nothing but the agent or agents. Okay, the agent or the agents. Understood this? So in the Davissian model, we have three factors. Okay, in the Davissian model, we have three factors: structure, time, process. Okay, structure, time, process. Davis. Okay, then the normal cycle of erosion. Okay, the normal cycle of erosion means what Davis actually has imagined. Okay, what Davis has actually imagined by the cycle of erosion or by the cyclic nature of the process. Okay, by the cyclic nature of the process is this normal cycle of erosion. He actually has studied the river. Okay, he has actually studied the river, and by studying the river, he came to know, or he observed that there is a sequence which is forming by the river, and by this sequence is getting followed by each and every river. It is not like that one river is forming this process and another river does not, right? So all these rivers are following one and the same pattern. That every river originates at the mountain, right, or a hill, then it is actually turbulent at the hill, at the slopes, right? When it comes on the surface or in a plain, it becomes wider. Okay, it becomes wider, and then it becomes some of a bit of calm and quiet and flows very steadily, very slowly. Okay, but at the same time it is an erosional agency as well as it is a depositional agency, right? And when it comes nearer to the sea, okay, when it comes nearer to the sea, it is actually slowed down. It is now a depositional agency rather than the erosional agency, right? So these kind of processes or these kind of observations he has done for numerous rivers, not just for one river, but for many rivers in his lifetime. And he has devised one theory, right? And that one theory is the Davissian theory, or which he called as the normal cycle of erosion. And this normal cycle of erosion has been derived from the river itself. And when and where it has not been stated that this cycle of erosion, you have to be understood or you have to be sure that the author or the question is asking about river itself, right? So let us see the normal cycle of erosion. So the erosion cycle of erosion by fluvial process is called normal cycle of erosion. Okay, the normal cycle of erosion, because the fluvial processes are most widespread. It is spread all along the world, right? And most significant geomorphic agent. Okay, it is the most significant geomorphic agent. Okay. Now, normal cycle of erosion begins with the upliftment of any landmass with reference to sea level, right? Like this, upliftment of any area. This is hills for the question. Okay, this is hill. As the land rises, the rivers are originated and their erosional work starts. The moment river starts flowing, okay, the moment river starts flowing, it starts its erosional work. Okay, it does not wait for anything. It does not wait for right time. It does not wait for right force. Does not wait for right flow. Okay, it starts its origin. It starts its down cutting. It starts its erosion right from the inception of the moment. Okay, so say suppose from this point the river has been originated. Okay, from this point the river has been originated and a small flow has started here, right? A small flow has started here like this. So it has actually started, okay, it has actually started the erosion. It has actually started the erosion, right? The rate of uplift in the beginning far exceeds the rate of erosion, with the result absolute relief and relative relief registered increase, right? So as the upliftment is going on, okay, as the upliftment is going on, if the rate of upliftment is larger more than the rate of erosion, okay, it is the rate of uplift exceeds the rate of erosion, right? So what happens, the uplift will go on and the river will again move along with the height. Okay, after some time upliftment of the land stops and erosion becomes more active, right? The land area tectonically remains stable, that is their crustal stability for long period of time, during which there is neither upliftment nor subsidence of land. Okay, there is only progressive erosion. Okay, one time comes when the upliftment stops. Okay, upliftment stops, that there is no further upliftment of the area, right? There is no further upliftment of the area and then erosion starts. Okay, then erosion becomes dominant process. Erosion has been started right from the inception, but it was not the dominant process. Now it is dominant process inside the eroded surface, okay, or the uplifted surface. Okay, so development of river valleys in sequential order and the whole land area progressively passes through three successive stages of youth, mature, and old stage. Okay, so the entire area goes through youth stage, mature stage, and old stage, and ultimately transformed into low featureless plain of undulating surface. Okay, thus the penultimate and product of normal cycle of erosion is called a peneplain. Okay, it is called as peneplain. Okay, which is characterized by undulating surface with residual convexo-concave low hills known as mono mononox. Okay, mononox, uncas, or musors. Okay, these are alternative names. Okay, these are the alternative names. You can remember this. Right. So in this diagram, these stages are given. Okay, the stages are given like this. Okay, so let us see the details of these stages. The first one is the youth stage. Okay, the first stage is the youth stage, right? So consequent streams. You might be aware of this consequent and subsequent and antecedent streams. Okay, consequent streams, say, streams and subsequent streams, and antecedent streams. These are the types of streams, right? So consequent streams, which are those which follow the regional slope. The entire regional slope will be followed by this stream. Okay, they are originate with the upliftment of land area due to endogenetic forces. Okay, endogenetic forces will uplift the area, right? Endogenetic force will uplift the area, and with uplift of the area, the original location of the river, which was at the plains, is now uplifted, right? So in the beginning, the streams are less in number and short in length. Very few tributaries of the master consequent stream are originated, right? The slopes are dominated by numerous rills and gullies rather than big streams. Okay, these rills and gullies lengthen their longitudinal profile through headward erosion. So there will be headward erosion as it is going by, because the slope is higher. Okay, because the slope is higher, the geograph this gradient is higher, right? The gradient is higher, and due to this higher gradient, the it will come with rapid rate. Okay, it will come down with the rapid rate or faster rate, and this faster rate will increase the will give go rise go for the active down cutting. Okay, the rivers are continuously engaged in rapid rate of down cutting of their valleys. That means if this is okay, this is the cross section of a valley. Okay, this is the cross section of the valley on the hill slope actually. Okay, on the hill slope, rapidly it by the down cutting, the valleys become like this. Okay, valleys become like this, deep valleys. Okay, deep valleys and V-shaped valleys. Okay, this V-shaped valleys like this, right? This is due to the active down cutting. Okay. This is due to the active down cutting of the river or by the rivers. Okay. So this valleys, okay, these deep valleys, they are called V-shaped valleys are called gorges and canyons. Okay, these are called as the gorges and canyons. Larger structures are there. Okay, larger structures are there. You might have heard about this canyon. Okay, the Grand Canyon, USA. Okay, the Grand Canyon in USA, right? So these kind of things, okay, these are the gorges, they are canyons, these are the structures which are formed, okay, which are formed along with this V-shaped valleys. Okay, okay. When there is youth stage, okay, when there is a youth stage, that is the initial stage, there is valley deepening. Okay, the valley deepening. So valley deepening is associated with youth stage. Okay, valley deepening is associated with youth stage of river valley development. Youth stage, right? Coming to the next part or next process, and that is the mature stage. Okay, that is called as the mature stage. Now, leaving the slope behind, okay, leaving the slope behind, river has now came into the plains. Okay, river is on the plains now. Now in the case of plains, there is a significant drop in the gradient like this. So the river was flowing here. Okay, river was flowing here on the slope. So it had high gradient, it has high gravity value. Okay, so that it could go for active down cutting, right? Active down cutting because of the force. Now such river when came on the plains, okay, when came on the plains, it lacks the gradient, right? It lacks gradient, and this lack of gradient or the loss of gradient goes for, or it occurs, or it does the active down cutting. Okay, in this case the active down cutting is reduced. Okay, active down cutting is reduced and valley widening occurs. Okay, valley widening occurs. It widens its own valley, right? So marked valley deepening through vertical erosion result in pronounced decrease in channel gradient and consequent decrease in flow velocity, which result in the arrival of early maturity heralded and marked decrease in valley deepening. Okay, so valley deepening is stopped, okay, or decreased. It does not stop, but it decreases. Okay, why it is so? Decrease in channel gradient, decrease in the velocity of river flow, decrease in the transporting capacity, right? All these things, right? All these things occur, and due to this, the active down cutting or the valley deepening restricts. Okay, valley deepening restricts. Instead, the valley widening occurs. Okay, valley widening occurs here. Okay. So the rivers deposit big boulders at the foothill zones due to sudden decrease in channel gradient and hence marked decrease in the transporting capacity of the river. Okay, these material form the alluvial fans or alluvial cones. Okay, these will form the alluvial fans or alluvial cone because whatever the material, because in case of youth stage, okay, in case of youth stage, river had more transporting capacity, right? River had more transporting capacity. As it came on the plains, the transporting capacity had lost, right? So whatever, due to this high capacity of flow, okay, high capacity of flow or high transport capacity, larger material was were brought by the river, right? Larger material were brought by the river with very ease. It is now impossible for the river to carry it any further, right? So it will deposit the material, or it will start to deposit the material at the foothill zones, right? At the foothill zones, like here. Okay, this is a slope from where material has come, but river is unable to take the material away from here, right? So what it will do, it will try to deposit, or it will deposit the material here itself. Okay, it will leave the material here itself and only take the smaller material or the lighter material which it can carry with ease. Okay, so these kind of deposit, okay, this kind of deposit forms the alluvial fans or alluvial cones. Okay, the gradual expansion of such fans and cones due to their continuous growth results in the formation of extensive Piedmont plains. So larger plains are there. Larger plains may form. Okay, larger plains may form, and these larger plains they are called Piedmont plains. Okay, so these kind of things they occur repetitively. Okay, they occur repetitively, and they form the floodplains. Okay, they form the floodplains, right? Even nature has its own protection mechanism. Okay, its own protection mechanism, which is called as natural levees. Okay, which is called as a natural levees, which along these rivers there are ridges. Okay, there are ridges which are formed due to deposition of alluvial material. Okay, deposition of alluvial material, they grow in size like 10 meters, 15 meters, right? And it prevents the flood. Okay, it prevents the spilling of the river, right? This is called as natural levees. Okay. And then the river has lost, okay, or the river loses its capacity to transport as well as erosion. Okay, its capacity of erosion as well as transport. It cannot erode any further. It cannot transport any further the larger materials or even the moderate or even the smaller materials. What it can transport? Just the sand size materials or silt size materials. Okay, sand size or silt sized materials, right? So we can conveniently call that old stage of river has reached. The old stage of river has reached now, right? Now here there are many tributaries which come. Okay, many tributaries have attained their base level of erosion. Okay, tributaries have attained the base level of erosion. Even the river itself or the stream itself has reached the this base level of erosion, right? So there is almost absence of valley deepening, decrease in the number of tributary streams, and flattening of valleys. Valley will become flat now. Okay, valley will become flat, or basically it tries to become the featureless plain. That is it is the conversion of peneplain. Okay, it is the concept of peneplain. Right, valleys become broad and flat, characterized by concave slopes of valley sides. Downcutting of the valleys is totally absent. Weathering processes are most active. Okay, weathering processes are most active. Thus, lateral erosion, downcasting, and weathering continuously degrade the land, resulting into gradual lowering absolute altitude and water levels. Right. So basically, river has reached. Okay, this river has reached the final destination. Okay, it has reached the final destination, and this final destination is nothing but it's meeting with the sea. Right, it's meeting with the sea. Now when this river, again, when this river deposits some of the material, okay, deposits some of the material at the mouth of the river, okay, at its mouth, okay, it will form a feature. It will form basically a triangular feature, which is called as delta. Okay, which is called as the delta. Right, so delta is formed at the mouth of the river. Okay, delta is formed at the mouth of the river, where sea and river meet. Okay, river and sea meets. Okay, so we have in India one delta, or the largest delta in the world. Which is the largest delta in the world? It is Sundarbans. Right, it is Sundarban. So the delta is so large that one entire country lies within the delta. Okay, our entire country lies within the delta, which is that Bangladesh. Right, Bangladesh lies completely inside the delta. Okay, so it is completely inside the Sundarbans. Right, so these kind of deltas can be so extensive. Right, this kind of deltas can be so extensive, and this kind of deltas can be so large as well. So the entire landscape is converted into extensive flat plain of undulating surface, except a few residual convexo-concave hills which project above the general flat surface and thus break the monotony of reliefless flat plain, which is called as actually peneplain. Okay, which is actually called as the peneplain, and the process of formation of the peneplain will be peneplanation. Okay, so this is all about the cycle of erosion. Okay, this is all about the cycle of erosion, or the normal cycle of erosion. Now, it is not like each and every agency, okay, each and every agency has the cycle of erosion. Each and every agency does not have a perfect cycle of erosion. Okay, just like river has the erosion cycle, but the wind does not have the erosional cycle. Glacier does not have a erosional cycle. Then groundwater does not have erosional cycle. Okay, and hence the river is considered, or the river valley is considered to be the normal cycle of erosion, right, or normal cycle of geomorphology, or normal geomorphic cycle. Okay, got this? Got this?
Yes, sir.
Shall I move forward? Okay. Okay, so if you are clear with this, I'll move forward with another topic. Okay. A small topic which is to be covered today. Okay. And that is hill slope. Okay. The hill slope or a slope. Okay. Now, slope, as you know very well, okay, as you know very well, slope is defined as angular inclination of terrain between hill tops and valley bottoms, resulting from the combinations of many causative factors like geological structures, climate, vegetation cover, drainage texture and frequency, dissection index, relative relief, and of course the individual processes including weathering, mass wasting, mass movement of rock waste, erosion, and transportation of eroded material downslope, etc. Right? These basically are the slopes. Basically, what slope actually is this angular inclination. Okay, this is the angular inclination. Right? This will be your slope. Okay, any angle with respect to vertical nature. Okay, with respect to vertical, right, with respect to vertical, so this angle will be called as a slope, right? So from the slope many things can happen, right? Mass fasting can be done, right? Rivers are originated on the slope. Okay, rivers, they are originated on the slope, right? So what we have to study here is the basic classification of slopes. Okay, the basic classification and characteristics of the slope. This is, in this diagram you can see, this is the slope profile. Okay, this is a slope profile. Here in this diagram the slope profile is given. Okay, so slope basically is divided into four factors or four zones. The first zone is called summital convexity. This zone, okay, this zone is called as summital convexity. Okay, then this surface is called as free face. Okay, then actual slope comes, it's not rectilinear. Okay, it is called as rectilinear, and then becomes concave at the base. Okay, it becomes concave at the base, which is called as basal concavity. Okay, this is called as basal concavity, right? So let us see these factors or these zones in detail. Okay, so there are the slope elements, four slope elements, as I have told you. Okay, slope elements or slope segments, right? The first one is the summital convexity. Okay, the summital convexity. The convex segment is found at the hill crest, that is the top. Okay, hill crest or the top, and this element is called as summital convexity. Like this. You try to draw any ideal slope. Okay, you try to draw any slope. You will draw, even if you don't know about this thing, that there is always a convexity at the top. You will draw a slope like this only. Okay, you won't draw you won't draw a slope like this. If you are if you are drawing a hill, okay, if you are drawing a hill, you will always draw the hill like this. Okay, in a cross section. Okay, in the cross section, this upper surface is the summital convexity. Okay, this upper surface is the summital convexity, right? So most of the summital convexity develops because of denudational processes, that is rain wash or soil creep, and that is why convex slope is also called as upper wash slope. Okay, this is also called as upper wash slope, right? This convex slope is convex element dominates the hill slope profile. It is also called as waxing slope. Okay, it is called as waxing slope. Okay. Next is free face. Okay, is the free face. Free face element of hill slope represents wall-like precipitous slope of bare rocks and is devoid of any debris. It is completely free face. Okay, completely free face. That's, you cannot climb it. Okay, you cannot climb it. Right. If there are cracks in the rock, you can climb it, but it is virtually impossible to climb this kind of free face. Okay, so this is completely bare rock. It does not have any kind of vegetation. It does not have any kind of debris as well. Right. Or the segment, the element or segment is called as slope of derivation because there is instantaneous downslope transport of material. So if you throw anything, it will simply come down. Okay, it will simply come down from the free face. Okay. Next is the rectilinear element. Okay, the rectilinear element. Now this rectilinear element is a straight or linear segment of hill slope profile between upper free face and lower concave element is called rectilinear element. It is also termed as constant or uniform or regular slope because of uniform nature of slope angle. Okay, so it is also termed as the constant or uniform. This is constant or uniform. This is basically uh, uh, gentle. Okay, this is basically gentle than that of this free face. Okay. So because of presence of rock debris, this element is also called as debris slope. There is a presence of debris. Remember, in the free face, okay, in the free face, there was no debris present. No debris present. Here, there is the presence of debris. Or okay, I'm sorry for the interruptions. Okay, so the angle of rectilinear segment is controlled and determined by the angle of repose of debris is called as repose slope. Okay, angle of repose means angle of stability basically. Okay, it is the angle of stability till angle of repose is the angle till which a slope or the debris can be stable. If this angle is crossed, okay, if the angle is crossed, the debris will come down, right? The debris will come down. That will be called as the angle of repose. Okay. And the last one is the concave element. The basal segment of an ideal hill slope profile is always characterized by concave element. Okay. So every time at the slope will end like this. Okay. The slope will end like this. The slope angle decreases as the segment of basal concavity increases. Okay. Length is there. If more or more length is there, then the slope angle will decrease. Okay. This is why the segment is called as waning slope. Okay, waning slope. Then waxing and waning in the in case of increasing and decreasing, that is called as the waning slope. So basal concavity is generally originated because of active denudation, mainly by rainwash, rails, and gully erosion. This segment may be covered with debris or may be of bare rock. It may be covered by the debris or it may be completely bare. It may be completely clear or it may be completely covered by the debris itself. Right. So these are the basic elements. Okay, these are the basic elements of the slope. Okay, so these are nothing but all these uh, elements which are given over here. Okay, you can have the look. Now, classification of the slopes. Okay, the classification of the slope. So the genetic classification of the slope. Okay, genetic classification. Obviously, genetic classification means the scheme of classification which depends upon its origin. Okay, the scheme which depends upon its origin. So on the basis of this, the slopes are divided into three types: the tectonic slope, erosional slope, and slopes of accumulation. Okay, the tectonic slope, erosional slope, and slope of accumulation. The first one is the tectonic slope, generally formed due to tensional and compressional forces resulting into the formation of fault scarps through faulting in the crustal rocks and due to tilting of the rock beds. Okay, so tectonic, just remember this, tectonic slopes are those slopes which are formed due to tectonic activities, right? Which are formed due to tectonic activities, that will be tectonic slopes, right? So it may be folding, it may be faulting, right? So there might be a slope which has formed due to such kind of activities. Okay. So scarp slope is the ideal example of tectonic slope. Okay. The fault plane has a fault scarp. That is that extension is called as fault scarp. Okay. So that slope is nothing but the tectonic slope. Okay. Next is erosional slope. They are generally formed due to erosion by rivers, glaciers, and sea waves. So Say suppose a large hill was present. Okay, large hill was present, but it was not that steep. Okay, its slope was not that steep, but due to erosion, some surface has been removed. Say like this. Okay, this hill was there. Okay, this hill was there. Now it has been actively cutted. Okay, actively cut by the rivers on this side. Okay, it was actively cut by the river on this side. So this slope has become like this. Okay, the slope has become like this. Okay, so this is called as erosional slope. Okay, this will be called as erosional slope. So erosional slopes are developed by river, undergoes sequential transformation and changes in different stages of cycle of erosion. Okay, the different stages of cycle of erosion. That means convex slope in juvenile stage. Okay, at the top, juvenile stage, in the youth stage, the convex slope will be there, right? Convex slope will be the rectilinear slope in the mature stage and concave slope in the older stage. Okay, so according to the flow of river, according to the water availability of the river, these kind of structures or these kind of slopes will be formed. Okay, then the slopes of accumulation, right? The slopes of accumulation. Now, what is the slopes of accumulation? The slope of accumulation is simply the slopes which are formed due to deposition of the eroded sediments. Okay, this is deposition of the eroded sediments. Whatever the sediments have been taken by the river or any agency like wind or like glaciers, it has been accumulated at one place and now it has grown so large that it has formed the slope. Okay, these are also called as aggradational slopes. Okay, these are also called as aggradational slopes, right? Volcanic cones also come under this category, right? So this will be called as, these are the three types of slopes which are formed on the basis of their genesis. Right. On the basis of stage of formation, slopes are classified into primary slopes and secondary slopes. Primary slopes are formed due to erosion by streams, glacier and sea waves. Secondary slopes represent major slopes developed by base of primary slopes. Okay, primary slopes formed by the erosion by the streams, glaciers, and secondary slopes represent the minor slopes. At the base of a large primary slope, there is a secondary slope or there is a minor slope which is called as the secondary slope. Right. Now, next is the quantitative classification. Okay, quantitative classification. The quantitative classification is the slope which is according to the angle. Okay, which is according to the angle. Okay, so it is level to gentle slope. Okay, level to gentle slope. That is level slope if the angle is 0 degree to 0.5 degree. Okay, very gentle slope. That is a level slope. Actually, it is flat. Okay, it's actually flat. Almost level slope, it is 0.5 degree to 1 degree. Very gentle slope is 1 degree to 2 degree. Right. So these are basically almost parallel to the land. Okay, almost parallel to the land, or almost flat. Right. Then comes gentle slope 2 degree to 5 degree, then moderate slope 5 degree to 10 degree, moderately steep slope 10 degree to 18 degree, steep slope 18 degree to 30 degree, very steep slope 30 degree to 45 degree, precipitous to vertical slope 45 degree to 90 degree, right? So this precipitous slope is 45 to 70 and wall like slope is 70 degree to 90 degree. Okay, so this is the classification. Okay. This is the classification of slopes which we have to study or which we have to look for. Okay. So this is it for today. This is all about today's class.